subscribe. Click on the bell. Like, comment, share.
Click on each of the graphics to find out more about soap and the active ingredient in soap-free shower cream. Soaps are water-soluble sodium or potassium salts of fatty acids. Soaps are made from fats and oils, or they are fatty acids, by treating them chemically with a strong alkali. Quote from the Soap and Detergent Association based in the USA. Based on the quote and your knowledge of chemistry, pick out the soap from the ingredients of the shower cream. Sodium palmitate is formed when palmitic acid is neutralized by sodium hydroxide. This is the structural formula of sodium palmitate. Soap is a salt formed from the neutralization between a fatty acid and an alkali. Look at some of the ingredients used in the soap-free shower cream. Which of the ingredients is the main active ingredient responsible for the cleaning property of this shower cream? Sodium lauryl sulfate is an example of a detergent which is responsible for the cleaning property of the soap-free shower cream. This is the structural formula of sodium lauryl sulfate. A detergent is a salt formed from neutralizing an alkyl hydrogen sulfate with an alkali. How do we make soap and detergent? To find out how they are made, click on each of the photographs shown. The preparation of soap in the laboratory can be divided into 3 steps. Click on each of the steps to find out. Step 1. Saponification. Pour 5 cubic centimeters of palm oil into a beaker. Add 30 cubic centimeters of 5 mole cubic decimeters sodium hydroxide solution to the palm oil. Boil the mixture for about 10 minutes while stirring with a glass rod. There are 2 separate chemical reactions in the saponification process. At the end of saponification, the solution now contains glycerol, excess sodium hydroxide, and soap. Step 2. Precipitation. Add 100 cubic centimeters of distilled water. Add 3 spatulas of sodium chloride. Continue boiling for about 5 minutes. Remove the beaker from the flame and allow it to cool. Common salt is added to the solution to precipitate out the soap from the solution. Step 3. Filtration. Filter the soap using a filter funnel. Then, rinse the soap on the filter funnel with a little distilled water. The soap is separated from the solution through filtration. The preparation of sodium lauryl sulfate, a detergent, can be divided into 4 steps. Click on each of the steps to find out. Sulfonation. Pour about 50 cubic centimeters of concentrated sulfuric acid into a beaker containing lauryl alcohol. Heat and stir the mixture for about 15 minutes. Allow the mixture to cool to room temperature. The solution now contains lauryl sulfonic acid. Neutralization. Add sodium hydroxide solution to the beaker containing lauryl sulfonic acid until there is no effervescence. Complete the word equation for the neutralization. Precipitate. Add sodium chloride to the solution to precipitate out the pale green sodium lauryl sulfate. Filtration. Filter the mixture to separate out the precipitate. Let us carry out a laboratory activity to compare the cleansing action of soap and detergents. We start by preparing 4 different types of solutions in beakers A, B, C and D. Record your observations of the 4 solutions in the table provided. Magnesium or calcium ions are present in hard water but not in distilled water. What are the differences when soap or detergent dissolves in hard water and distilled water? Based on your understanding of the relationship between the amount of active cleansing agents and the amount of foam formed, predict which of the following solutions will be the least effective. Now let us carry out the experiments and watch and record what happens. Put a piece of the salt cloth into each beaker. Stir the contents in each of the beakers with its own glass rod. After a few minutes, rinse the 4 pieces of cloth. Your prediction is correct. Study the box of brand Z detergent. There are 6 added features that meet the needs of the consumers in the cleansing action of this detergent. Find out what they are and how they function. Chemical compounds such as optical brighteners, SUTS stabilizers, and others are usually chemical compounds added to detergents to enhance their effectiveness as cleaning agents. They are also known as additives to detergents. Chemical compounds that are added to detergents to enhance their cleaning effectiveness are known as additives. Optical brighteners. The extra shine in colored and white fabrics are caused by optical brighteners. They work by depositing fluorescent dyes on fabrics during laundering to enhance the brightness of light-colored fabrics. Their effect is cumulative, so new fabrics exhibit increased fluorescence after several washes. Enzymes. Enzymes are used in detergents to break down large water-insoluble soils and stains, such as blood, which are attached to fabrics, into smaller, more water-soluble pieces. Examples of enzymes used in detergents are proteases, amylases, cellulases, and lipases. SUTS stabilizers. SUTS stabilizers are included in detergents to boost foam production. They help to increase the amount of foam produced and maintain an optimum SARTS level for maximum cleaning power. Perfumes and fragrances. Perfumes and fragrances are added to provide a scent to the detergent and clothes. They make the clothes have a sweet, pleasant, and fresh smell. Bleach. Using bleach will remove the overall greyish appearance that white fabrics may develop over time. This additive will make white fabrics white again. An example of a bleach used in detergent is sodium percarbonate. Dye transfer inhibitors. Dyes that are washed out from colored fabrics must be prevented from redepositing themselves on other fabrics. Dye transfer inhibitors, or DTIs, are color care chemical compounds that bind irreversibly to free dye molecules in the wash water and form water-soluble macromolecules. This way, the dyes are prevented from redepositing onto garments and are removed with the spent wash water. In this lesson, we have learned that there are two main types of cleaning agents. They are soaps and detergents. Detergents are made from alcohols and alkenes, usually from petroleum. Soap are made from vegetable oils or animal fats. They are hydrolyzed and then neutralized in the saponification process. The salts or the fatty acids produced are known as soap. Alcohols and alkenes are converted into organic acids by the sulfonation process. The organic acids are then neutralized by sodium hydroxide. The salts from this process are known as detergents. Both soap and detergents are effective cleansing agents in soft water. In hard water, soap becomes less effective as scum, which is an insoluble precipitate, is formed. The amount of soluble soap is reduced. Less foam is seen to be formed. The reaction between the detergent and the magnesium ions in the hard water does not produce scum or any insoluble precipitate. The detergent remains effective as a cleaning agent. Some additives and their functions in detergents. Additive, optical brightness. Function, to add brightness and whiteness to fabrics. Additive, enzymes. Function, to remove food and other organic stains from fabrics. Additive, SARTS stabilizers. Function, to boost foam production and keep the foam from decomposing. Additive, perfumes and fragrances. Function, to give the sweet and fresh scents to the detergent and clothes. Additive, bleach. Function, to remove color or whiten fabrics. Additive, dye transfer inhibitors. Function, to prevent redeposition of washed-out dyes on fabrics.
Thanks for watching. Please subscribe and hit the bell icon.